at the Jacobs Institute, as well as those joining us virtually. Welcome to our 12th annual college internship presentations. I'm Jessica Martinson, a program manager here, and I'm so happy to introduce our interns today and celebrate their hard work. This summer, we hosted 6 talented interns from across the United States as well as internationally, bringing our total alumni to 63. We partnered with Power Up Tech, a program focused on attracting and retaining talent in our region. Through their partnership, our interns have participated in a tech design challenge, networking events, and explored Buffalo through social activities. One intern even joined their housing program for the first time and made fast friends with a group of M&T interns. A great example of how these experiences extend beyond just the workplace. As many of you already know, the Jacobs Institute is a truly dynamic environment, and our interns have taken full advantage. It's been such a joy to watch them arrive, eager to learn, dive into their work, and grow over the past 10 weeks. And I've learned from them as well. Whether just new software tools, creative uses of AI and automation, or simply the latest slang, which I'm sure I will never use, but it's good to know what people are talking about. Before we begin, just a couple of quick notes. Please hold all your questions until the end. We'll come around with a microphone. And finally, we invite you to join us for a reception at the end in the Jacobs Institute across the hall. Now, I'll pass it to Carson to get us started.
Awesome. Thank you so much for the warm welcome. My name is Carson, and I'm one of the engineering interns at the Jacobs Institute. I study computer science and electrical engineering at the University of California, Berkeley, and I'm super excited to kick us off. Let's see. Oh, this slide. Oh, there we go. So as a CS major with probably the least background in medicine amongst all the interns, it has of course been bestowed upon me to describe endovascular surgery to this audience. Right below us in this building, over 100 people are treated every day with endovascular procedures. Dr. Nick Hopkins, who is the founder of the Jacobs Institute, championed the idea of using the vascular system as a highway to access diseases all around the body. How to do this exactly, though, is with catheters. Catheters are effectively just polymer tubes used by physicians to get wherever in the body they need to go. So one way we reinforce catheters is with coils. Coils are basically just thin metal filaments tightly wound around the catheter and then reflowed, which is just another word for melted, to the catheter sidewalls. This provides the catheters with kink resistance. We can see the impact this makes right here because the clear plastic tubing on the bottom was not reinforced and when bent, kinked, but we see that the one that was reinforced didn't. The ability to make sharp turns without kinking is necessary to navigate highly tortuous vessels, as shown in the X-ray on the right. So the machine that the JI engineers use to make these is aptly named a coiler. If you're sitting on this side, it is right there. And before I got here, some of the JI engineers need to make a coil-reinforced catheter, but lead times for commercial coilers were multiple months, and engineers needed something sooner. So they built their own. This was a minimum viable product. It got the project done, but with future projects in mind, it needs some upgrades. In a display of engineering efficiency, the original coiler had one button. This was the power switch. It would run the moment you gave it power, and it would not stop running until you turned off the power. This was a little bit like standing at the top of a hill with a sled, and then just aiming in the right direction, giving a good push, and just hoping for the best. Problem is, if you ever want to stop and see how you're doing, you basically would just have to bail into a face full of snow and tears. So, additionally, if you want to change the settings, you had to go into the Arduino code and manually change the inputs. So the process of doing this would be unplugging the motors, uploading the change code, cutting the power, plugging the motors back in, turning the power back on, and praying you did not add or forget an extra zero. You can probably imagine that when you're prototyping catheters, this is not the most efficient workflow for doing this. We also need a way for the users of the coiler to create and construct their designs without having to re-upload code every time a change was made. On top of this, continuing with the sledding analogy, we needed to replace the unsustainable coil design model of push in the right direction and hope for the best. Users need the necessary data readouts to be able to detect deviations from the desired product as soon as they arose, and they needed the fine-tuned control capability to correct these deviations. So we need a place to put all these things, so let's build an app. 7,000 lines of code later, we have this. This is just a quick demonstration of the process of designing a coil and controlling the catheter coil, all within the app. So a few of you might be wondering why build an app for this? Why not just add more buttons and switches? I don't know if any of you guys have read If You Give a Mouse a Cookie, or it's a version that didn't sell as well, If You Give an Engineer a Button. But if you know what I'm talking about, you know the problem I was trying to avoid. For me, what was more important was future-proofing this thing. I didn't want this to just be good for the 10 weeks that I'm here. I wanted this to be able to be rapidly iterated at the same rate that the coiler is being iterated. Another part of this, too, that I really just wanted to emphasize is that this app really is not that fancy nor hard to change. The reason why I want to emphasize that is because, say, somewhere down the line, the JI has another tool or machine that they need a similar interface for. They can just take what I wrote already and then just be more than halfway done. And so sort of building upon this, I just really want to get across that it's a lot simpler than it seems. So everything the user sees is constructed with HTML and CSS code. Fun fact, that's also websites or most apps you use. It's all basically the same thing. However, JavaScript is responsible for loading the pages in the first place, and for our purposes, sending and receiving data from the controller through a Node.js server. And then an Arduino script controls the coiler motors. So I just want to kind of give a quick rundown of how pressing a button on the laptop moves motors in the real world. So I'm just going to work through that. Like I said already, all buttons, readouts, and their appearances are designed in HTML and CSS. Some buttons communicate with JavaScript code, but most of them just modify parameters within the HTML script. However, certain buttons that are important, such as the run segment button, will communicate with the JavaScript because it needs to move motors in the real world. I'm going to run through how that framework works. So part-time employee Josh Allen has decided to design a catheter coil and now wants to construct it. He clicks the run segment button, and HTML tells JavaScript that we need to construct a coil with his chosen characteristics. We have a problem, though, at this stage, because JavaScript and Arduino script cannot directly communicate with one another. A very easy workaround for this, though, is just using a Node.js backend. By running a Node.js server in the background, the JavaScript and Arduino script can communicate with one another across it. That's all it's doing. Don't overthink it. Josh Allen can now design a coil on the app, click a button, and have a coiler constructed. So sort of a few takeaways for me as my presentation is winding to an end and the internship itself. I'm really kind of thinking a lot about my worries I had at the start. So like I said, I'm computer science and electrical engineering. My background's mainly in microrobotics, microfabrication, computer science. I have zero medical experience. I had no idea what a catheter was before I got here. So, I was taking a leap of faith. I wanted to apply my skills to an unfamiliar field, but I didn't know if I was biting off more than I could handle. I didn't know if I didn't have the prior coursework to make a difference here. But what I quickly learned about the Jacobs Institute is that it's dedicated to cultivating a diverse team, so much so that's in the construction of the building itself. On this floor, we have engineers and educators, and one floor down, we have heart surgeons and brain surgeons, not on separate wings, but all in the central hub designed to cultivate these collisions between fields. And in my experience, approaching problems just in a different way than you have been is the definition of innovation. So just being part of an institution where I'm a cog in the wheel of something where that's so ingrained in the overall process has been really important. And it's been an excellent experience for me, and I feel like I've been able to bring my strengths to this. For example, my main project was the coiler app, but I also got to work on a script that automatically reads data from the fancy scales that the JI has and writes them to an Excel sheet. That, and then I also wrote a automated text messaging service that hopefully should replace the existing email survey service. So if that doesn't work, you know who to blame. So thank you once again. This has been an incredible opportunity. I'm really thankful to be here, and I'll be passing this off to Riley.
Good job. Okay, hello everyone. Thank you, Carson, for the introduction. My name is Riley. I study mechanical engineering at the University of Connecticut, and this summer I had the privilege of working as an engineering intern here at the JI. I worked with the R&D team to develop compliant vascular models, and I'm excited to tell you about that today. So first, we need some background. What are vascular models? Vascular models are things that represent what's happening inside your body that doctors can use to test new medical devices, learn new procedures, and educate new doctors. It's important for the model to accurately mirror the biological anatomy of the vessels so that the model training and device testing can translate to patient care. For example, if the model doesn't accurately resemble the environment in the body, you can design a device that works very well in the model, but this might not work well in a patient's body. So in order to avoid this, the JI uses several different materials in order to achieve different model properties. Examples of these are glass and SLA, which are rigid, and then polyjet. And polyjet is flexible. The choice of the material depends heavily on the purpose of the model. Now let's look at the polyjet flexible material more closely. Flexible models need to be compliant, which means that they change their shape depending on how much pressure you apply to them. Let's look at the current limitations of the flexible models. So this is an actual patient scan, and here you can see in the first image that this is a fluoroscopy image of an artery with a contrast injection. You can see here that there's a loop in the artery. As the doctor inserts the guide wire, you can see that the loop is still there. But as the catheter is inserted, the loop straightens out. This means that the vessel is compliant, and it responds to the catheter being inserted into it. We need a way to make models so that they are compliant. Let's look at the current models that we're using. These are the flexible polyjet models we talked about earlier. You can see in this first box that there's a loop that's similar to the patient scan we just looked at. Now, as we advance a catheter and a guide wire through it, you can see that there's very little geometric change to the model. This means that the model isn't compliant enough to mirror what's happening inside the body. So we need a way to create models that are more compliant. In order to do this, this is where my project comes in. Engineers at the JI had an idea of what materials would work to create these models, but they didn't know exactly how to form them into the shape of a blood vessel. This is where we use dip casting. Dip casting is comprised of 4 main parts. First, you create a mold. Then you create a solution, which is consistent of a polymer and a solvent. Then you dip the mold into the solution and then retract it. As the mold is drying, as the solution dries, the solvent evaporates, leaving behind a thin layer of polymer. After that, you remove the original mold to reveal the finished model. Now, with the dip casting process, there are parameters that we can vary that will affect the kinds of models that we're able to create. The first 2 parameters that we investigated were speed and the number of dips. So we tested a wide range of speeds and number of dips to evaluate how these parameters affected this process. Here's before dipping, and then here's after. Then we dissolved all of the original molds to reveal these models. We needed to evaluate the wall thickness. Let's talk a little bit more about that. So to evaluate the wall thickness, we looked at 2 locations on the model, the top and the bottom. The top refers to the point in the mold that is furthest away from the surface of the solution when we dip the mold. Then we wanted to evaluate the wall thickness of the model. The wall thickness refers to the difference between the inner and outer diameter of the model. We had 3 main hypotheses about what varying these parameters would do to the models that we were able to create. First, we were hoping that the model wall would be thicker at the bottom than the top. This makes sense because as the solution dries, it drips down and pools slightly at the bottom. Next, we thought that wall thickness would increase with the number of dips. As you're depositing more polymer around the outside of the mold, it's creating a thicker wall. Then, we were thinking that as the wall thickness increases, the wall thickness would increase as the speed also increased. This is because as you retract the mold at a slower speed, the solution has time to flow off and creates a thinner, more even model. Now this is what we thought the data would look like. And then we actually measured it, and it looked like this. It looked nothing like we thought it was going to, and the process wasn't consistent enough to see a clear trend. Now consistency is very important when creating models. 1, because you want the specific model you create itself to be consistent. You don't want part of the wall to be thinner than others because this could lead to it bursting. And you need to be able to replicate the same model multiple times. Now, in order to improve this consistency, we looked at two main factors. First, we looked at the surface texture. When we look at the original molds that we were using, the surface of them was very bumpy, and this translated to the model that we were able to create. The wall thickness was very inconsistent due to the surface texture. When we tried this on a smooth surface, however, we saw that the model that we were able to create was much more consistent. Next, we looked at solids content. Now, I know this graph is a little bit to look at, but let's talk about it. On the right side of the graph, you can see 6.5% solids content. Solids content just refers to the amount of polymer that's dissolved in the solvent. Dissolving more polymer will create a thicker solution. So 6.5% solids content refers to the thicker solution. You can see that the data points that we collected around the circumference of the model are very scattered and the spread is very wide. But when we dissolved less of the polymer in the model, or in the solution, we were able to tighten up the spread of the data, leading us to believe that this is helpful to create a more consistent process. Now, after developing this process to be more consistent, we were ready to test it on models that were more similar to the body's blood vessels. I made these models in SolidWorks, which is a CAD software, that mirrored common carotid artery geometries, and we dipped them in the same solution as before and removed the inner molds. We needed to test a model with a curve to evaluate the vessel compliance, like we talked about earlier. You can see in this video here that as we're inserting a guide wire into the model, it bends in the same way that we saw in the patient scans. It straightens it out, which leads us to believe that these models are more compliant. Then we tried the same process with real patient scans that we collected from the Gates Vascular Institute downstairs. We printed the molds in PVA and dipped them using the same process, and then we removed the molds to reveal the final model. You can see in this video here, we're inserting both a guide wire and a catheter into the model. We can watch as it straightens out to match the shape of the catheter, indicating that it's compliant. In other words, though it isn't perfect, this process is a great start when it comes to designing models in the future. We now have a way to create a model that is able to comply to the catheter insertion. So, what's next for dip casting? So something that I didn't specifically work on this summer was quantifying the anatomical properties of blood vessels in order to make our models mirror those. The JI team can evaluate the geometric properties of the body's blood vessels and use that data to create relevant models using this process. Maybe the models that we created had too thick of a wall, or maybe they were too compliant. We can learn about this by talking with doctors and using their insight to inform next steps in our process. We can also vary the mold materials and evaluate how what we make the mold out of interacts with the solution while dipping. Finally, we can test different solvents and polymers in order to tailor the process consistency and model properties to our needs. So, working at the JI this summer, I didn't only learn about dip casting. I have 3 main takeaways that I've gotten from my time here, and I'd like to share them with you all. First is that when you're analyzing data, it's just as important to evaluate the spread as it is to evaluate the trend. You can't claim that you have a trend in your data if it actually looks like this, right? It's too varied, and you need to be able to make your process more consistent and repeatable. Next, I learned so much about the design process with regards to rapid prototyping and problem solving. There were many times this summer when my fellow interns would walk by the lab and say, "Oh, Riley's doing her arts and crafts again," because I would have rubber bands, binder clips, and paper clips strewn across the desk. But I learned that in order to answer the questions that you need to and to gather the information that you want, you don't always need a pretty solution. It can be a short-term solution that guides the rest of your process. Finally, I learned about the importance of SolidWorks and CAD software. Now, CAD software is computer-aided design, and it allows you to model something on a computer before you create the part. Having no prior background in this, I was able to study for and pass the CSWA, which is a Certified SolidWorks Associate exam. I also didn't only learn about the specifics of using this software. There's a specific engineering mindset that goes into using software like this. You have to kind of know where you're going to end up before you start, and thinking in that way has been very helpful for me. Finally, I'd like to say thank you to everyone at the JI for their help this summer, especially to my mentor, Dan. At the beginning of the summer, Dan told me that my job was to learn, have fun, and be useful. And I'm glad that I'm so grateful for his guidance in achieving those 3 goals. I'd also like to thank Ariana for her wealth of knowledge, not only about vascular disease, and also for being willing to help at any time. I'd also like to thank my fellow interns for their support and friendship this summer, as well as the rest of the JI team, who has made this such an incredible environment to work and learn in. With that, I'll hand it off to Derek, who will tell you a little bit more about a different kind of model that he created. Thank you.
All right, thank you for that handoff, Riley. My name's Derek. I'm one of the engineering interns working with the Jacobs Institute this summer with the model development team. I'm currently an undergraduate studying biomedical engineering at Johns Hopkins, and I'm really excited to show off what we've been working on this summer. With the help of everyone at the JI, we were able to not only develop, but also produce a training model right over there for peripheral artery disease. Let's start with some background. What is peripheral artery disease? Well, these are the arteries of your lower leg. Normally, they're supposed to deliver nutrients from your heart to the rest of your lower body, yet this can be blocked by vessel wall buildup, which we call plaque. It starts with infections and maybe slow healing wounds, but can lead to amputations if left untreated. Anything in the arteries is considered plaque, and its buildup is what we actually call a lesion. Depending on the composition of this plaque, whether it's calcium, smooth muscle cells, fat, or blood clots, a different tool and therefore a different procedure is required each time. These are tools like using tools like angioplasties, where a balloon is used to push fattier plaque against the walls of the vessel, combined with stenting, which actually keeps the vessel open. Alternatively, for harder, more calcified plaques, clinicians may opt for an atherectomy, which uses a rotating blade to literally clear the plaque off of the lesion walls. Altogether, tools like these contribute nearly $5 billion into the peripheral vascular market. Yet, if we look at existing models for the peripheral vascular system, most don't cater very well to PAD. They could be made of silicone, simulating flow correctly, but completely ignoring the vast array of different lesions. Or maybe they do include lesions, but do so with ex vivo tissue, leading to not only very costly models, but also relatively unstandardized models. Clearly, endovascular companies need a more reliable means of simulating different lesions. In close collaboration with the rest of the JI, this was my solution. It's a vascular mock-up of the peripheral arteries. In other words, it's a modular training kit that can be used to demo stenting and atherectomy devices on artificial lesion inserts that I've built into the upper lower thigh and as well as the lower leg. There are 2 main parts to this. There is the outer casing, which is comprised of the skeleton's contour as well as access points that are compatible with most standard catheters and guide wires, as well as the model vasculature itself. This comprises all the arteries of everything from your aortic bifurcation all the way to the arteries below your knee. There are also 3 segments for artificial lesion inserts, which I'll get more into in a second. Unlike existing models, we've built this kit to both look like and function like a leg, with a compact and fully modular design, a 1-to-1 scale of human vasculature based off of representative clinical data taken just downstairs, and of course, custom lesions using the multi-material print properties of the printers here at the JI that mimic the existing morphology of lesions that clinicians might actually see in practice. Before I dive into the specifics, I want to specify that the first 3 weeks of my time here was actually spent conducting the necessary market research and risk assessment. What are the common practices? What are the common plaques, the common lesions, the common tools? And all of this information actually went into justifying my design choices. Back to the model. The first step in using this model is to design your cartridge, which in and of itself has 3 steps. The first is to select a cartridge design. From there, you can actually choose what goes on inside of the vessel itself, and from there, all that's left is to generate, build, and print your cartridge. Let's select a cartridge design. There are 2 you can pick from. Cartridge A is a 2-part cartridge that comes together using screws, and it's suitable for procedures like stenting, since these don't actually damage the vessel. Instead, it just pushes the fattier plaque to the vessel walls. These can be operated on, assembled, and disassembled as many times as needed without damaging the vessel. Alternatively, you could opt for a disposable break-apart cartridge with a natural seam for one-time procedures like atherectomies. Since these actually shave away the plaque, they can only be performed once. However, these cartridges are simpler. They print in one piece and can be operated on as normal before snapping in half and breaking along that seam for viewing purposes. Once you've selected the right cartridge for the procedure, you can actually choose what goes on inside of the vessel. Research showed that the main parameters influencing tool selection was length, how long is the lesion, 10, 20, 40 millimeters. How severe is the blockage? Is it 25%, 75%, a complete blockage? We call that a chronic total occlusion. Is there a calcium present, and if so, to what extent? Is it jammed in the middle like you see here? Is it concentric around the vessel wall, or is it diffuse throughout the plaque? And lastly, are there any biological artifacts? Things like thrombi, blood clots, decaying cells, we call that a necrotic core. All of these can be controlled within the back end. Speaking of, I've designed the lesion plaque itself to be modular, meaning that all the end user, in this case the JI engineers, need to do is select what features they want and to what extent they want it done. Here you can see that each feature builds upon the last, making it incredibly simple to actually design a cartridge. Let's actually walk through generating a sample lesion for a rotational atherectomy. First, literature suggests that these tools are usually suitable for very dense, multi-layer fibrous plaques, so I've selected that feature. From there, these operations typically operate on very heavily calcified plaques, so I've gone ahead and changed the material assignment from a fattier plaque to a more calcific plaque. Lastly, some lesions for rotational atherectomies might contain an artifact like an acute thrombi, so I've selected that as well, and from there, I'm ready to print. Moving on to the rest of the model, I want to emphasize that this vasculature was designed from data taken just downstairs, which ensures accurate peripheral representation. We started with patient scans. From there, extracted the central line, which actually served as the basis once modeled in SolidWorks for the rest of the vasculature. You put everything together, and you have the final product that I showed you in the beginning. It's a fully functional PAD simulation and demo kit that can simulate lesions for a multitude of operations. Quite frankly, I really couldn't have asked for a more exciting or a more insightful project, as this was such an amazing experience in the design process. So much creativity and ideation and iteration went into everything, from those initial proof of concepts to the initial revisions, of which there were 3, all the way leading into that final version. Some highlights include the initial sketching of everything. Again, the lesions, the vasculature itself, as well as the, actually becoming accustomed to the amazing equipment we have here at the JI. So many test cartridges were printed and refined. And also, I mentioned a little bit about selecting a representative vasculature before, and by that, I mean that I had to characterize 30 patients' vessel complexity in order to select an average size vessel shape or tortuosity, complexity, sorry, for each major artery. In this case, for the aortic bifurcation, I'm going to select a patient right in the middle, looks like patient 25. And do you remember that breakaway cartridge that splits in 2 for easy viewing that I was talking about earlier? Well, so many decisions went into the actual engineering of it. What material do I make that break seam out of? How thick do I make that break seam as well? I don't want it to fall apart in my hand, but I definitely want it to hold up during an operation. So thankfully, I had an Intern to help. These are able to quantify the amount of force it takes to break something in half, and with this, I was able to answer some questions. I learned that, one, the thickness matters much more than material, as that was the principal determinant in the amount of force needed to break the cartridge in half. Additionally, I learned that with a sample size of 5, that these materials break extremely consistently, which is very helpful from a quality control standpoint, but also validates my design, ensuring that these cartridges will break very, well, consistently. And of course, the most insightful part about the summer was working with the amazing people at the JI itself. The JI is really such a special place in Western New York and quite frankly, across the country, and you cannot describe how amazing of an experience it is to work here until you've really spent a summer here yourself. I've learned that I find this career just so incredibly fulfilling, and I really see myself here see myself in this industry in the future. And a big reason for that is because of how heartwarming and welcoming everyone here was. To all of my interns and all of the JI folk here in the conference room, I want to say that you guys have really affirmed my decision to really want to be in this industry, and you guys have set the bar so incredibly high. So really, from the bottom of my heart, thank you for giving my career the kickstart that I did not know it needed. Thank you. And with that, I'd like to introduce Bianca, our next engineering intern.
Thank you, Derek, for that incredible presentation. I'm very excited to tell you about mine. My name is Bianca Philippone, and I'm an engineering intern here at the JI. I attend the University of Florida, and I'm studying biomedical engineering on the pre-medical track. But my project this summer was very research focused, but before I get into that, let me explain to you the importance of it. So a big question that's consistently asked around here at the JI is, how can the JI identify where to invest research and development for new products to stay ahead in the endovascular space? In other words, how can the JI anticipate the needs of our end users through observing areas of high innovation and growth? So let's say we're a JI employee interested in understanding the complex market landscape of endovascular devices used to treat brain aneurysms. Before this summer, this is what would pop up. All these crazy websites that become easily overwhelming and you're unsure where to start. And now imagine every disease state within a body and all the devices that treat those endovascularly. Thankfully, I'm here, and I did this research, and I started with the first website, and here's how I documented it. I tried to absorb as much information as possible and tried to categorize it as much as possible with all these tabs and indents. But as you can see, it's still very messy and hard to navigate when you have specific questions that need to be answered. So with the guidance of my mentor, we decided the most efficient means of categorizing and organizing this data was through Google Sheets, which takes you to my database. This is a 214-row, 18-column sheet that is to be built upon that has information spanning from disease states to the devices that treat those, companies that make those devices, market statistics, developmental statuses, and even customized notes about each device within the spreadsheet. So because this is such a big database, I've created a how-to-use sheet, which is going to be the first sheet within the Excel file itself. This contains information on how to interpret this data and even discusses some discrepancies that pop up due to the finite information available online. Before we get into data interpretation, I would like to talk about a few key features within my spreadsheet. The first are the notes. These are Google documents of information about each device with key features highlighted in blue. This allows the JI to compare between old and new devices and see which technologies are new and upcoming. Next, we have market research links. This is one big Google document containing all the links, categorized by column, that I have used to find all the values within my spreadsheet. And this will allow the JI to look at values and compare them over time. Now getting into data interpretation. There are two main ways to interpret my data. First is through a Pareto chart, also known as the 80-20 rule, where in this case, 80% of the growth is contributed by 20% of the population. This allows us to look at where there's high areas of growth and innovation. Another way to interpret this data is through queries, which is a means of filtering specific outputs you want to observe. In this example, I just outputted the top 10 devices with the highest growth rates in descending order. but you can do this with keywords and other value amounts to see whatever you want, which will be shown in the next slide. So now we know some key features, let's see how this works. Another way of filtering the data is through a pivot chart, which is done on a separate sheet. Again, this is just a way of filtering data and allowing it to be a little more organized with just showing what you want. In this example, we'll look at diseases, devices, companies that make those devices, and the average growth rates of them. As you can see, this is a little more organized, just shows what you want. If you want to filter this even more, you are able to add a slicer. In this example, we'll look at devices and we'll use carotid stents. This basically just filters what you just filtered. So all the information that you see pertaining to carotid stents will pop up. Now, if you're not as tech savvy as I was in the beginning of the summer, you could also just add a filter to the spreadsheet itself on a column. You can do this with any column, and all the information that I've inputted into this database will pop up depending on what you filter. Now, besides just filtering data, as I explained before, queries are a great use to show this information. In this example, I want to know how many devices are in each developmental stage for each company inputted into my database. The first columns that will pop up are unmodified data from my database. The third column will be a count of all the devices that I want. This is a good example that as you update the database, queries and charts will also automatically be updated. As I said before, this can be done with any type of query that you would like to see right in front of you. So let's go back to pretending we're being a JI employee, and we want to identify an area of high innovation and growth. So I create a Pareto chart. On the x-axis, we see disease states, and on the y-axis, we see the average growth rates of all the devices that contribute to each disease. If you look at the third bar from the left, we look at brain aneurysms. We can see that all the devices that contribute to treating brain aneurysms has a high potential of growth and innovation. So let's look there. Then I make a query. Oh, but first, what is a brain aneurysm? It is a weakened and bulging area on the blood vessel in the brain. Devices such as flow diverters, intrasaccular devices, coils, and clips all treat this one thing. This is an example of the wide range of devices that just treat one disease. Then again, imagine all the diseases within your body and all the devices that can endovascular treat that. Now I'm going to create a query. Just filtering all the columns that I want to see and the keyword brain aneurysm, all the information within my database pops up into this query. This shows the JI, who is involved in this space, and what technologies are showing improvement. If we want to go one step further, we can create another Pareto chart comparing just the devices that treat this disease. As we can see, flow diverters contribute highly. So maybe this is an area that JI should look into. So now that is my project, and how is this important? It optimizes the medical device research process. So as Derek said, his 3-week research process can now be cut down using my spreadsheet, hopefully. Highlight important anatomical regions to guide new model construction, offer detailed insights into market trends, and provide a clear framework for managing diverse sets of information. Over the past 10 weeks, researching and building this database, I've learned a lot. The first thing is that trial and error doesn't only pertain to scientific experiments, but it also is utilized when finding the most efficient strategies to do the work that you do. I also learned a lot about Google Sheets. Before the summer, me and Google Sheets were not friends. I had no idea how to make a pivot table, and I could not explain to you what a Pareto chart is, and here I am now explaining all of this to you. Another thing that I learned is efficient ways to find crucial information. I'm in a research lab back at UF, so I thought I'd be good at this. But then when you get into finding these small startup websites that are underdeveloped and trying to find international information, it's not as easy as you think. So I had to learn how to dig deep into Google and be patient with my research. I also learned a lot about vascular disease and medical device development. I even got to shadow how the JI creates a catheter in-house. I got to shadow surgery, both in the cath labs and in brain surgery, and that was an unforgettable experience and just fuels my passion to go to medical school. Last but not least, I love Buffalo. As a native Rochesterian who was raised in Florida, I was blessed with being here this summer to spend so much time with my family and my new friends. We got to enjoy all that Buffalo has to offer, and I'm so excited for the next time that I'm back here enjoying this. Go Bills. And as I wrap my presentation, I would like to express gratitude to my great mentor, Adam, and Dr. Siddiqui for all the guidance and support throughout this process, and to the rest of the JI team for making this such an incredible experience. I also want to thank my fellow interns for making this summer as fun as it could be. I'm eternally grateful to have worked at the JI with such an incredible team. Thank you all for listening. And I will now pass it to Catherine.
right. Thank you, Bianca. Good afternoon, everyone. My name is Catherine Flaherty, and I had the privilege of serving as the education intern at the JI this summer. A little bit about me: I attend the University of Alabama, where I'm studying kinesiology, and I'm applying to medical school this summer. To begin my presentation, I'd like to talk about the vision of the JI. The vision of the JI is to improve the treatment of vascular disease in Western New York and the world, while fostering local economic development and honoring the memory of Dr. Lawrence T. Jacobs. I feel that the JI vision is very complementary of our education mission here, which is to engage students with hands-on learning about disease prevention, as well as exposing them to careers in healthcare. We hope to fuel the ambitions of our future workforce and overall build a healthier Western New York community. So why is education important? Well, early exposure to awareness about vascular disease will hopefully lead to healthier lifestyle choices down the road. It also inspires the future of our healthcare workers, leaders, and innovators. Right here in Buffalo, we're developing diverse local talent and hoping to keep it local by showing all that the JI has to offer. We are a world-renowned endovascular innovation center. Also, everything that the students are learning here at the JI is connected to the local vascular disease crisis, making it very personal to the individual. Overall, we're hoping to educate and build a healthier Western New York. So a bit about our education programmings. Here at the JI, we have brain boot camps where local organizations and groups of students can come to learn about vascular disease, its prevention, and how we're working to treat it here at the JI. We also have our college internship program, which y'all are here listening to our presentations today. My peers and I were assigned projects based on our interests and skills, as well as the needs of the JI. We have the JI Next Gen High School Internship, which it was my primary role to plan and execute this internship. This year, we had 27 high school students from all over Western New York come to learn about careers in healthcare, as well as everything that we're doing here at the JI. And finally, we have the Jacobs Scholars Program, where 2 Nichols students are selected as freshmen and return to the JI each summer through their graduation to explore careers and learn skills pertaining to the biosciences. So the JI Next Gen High School Internship. This year, it was centered around a research project that I created. The students worked in teams and researched and then got to present their projects at the end of their 2 weeks at the JI. They were also able to attend a lecture series from our very own Dr. Snyder, who tailored his curriculum to really complement their research projects, which was super cool. They also heard from various guest speakers from all across the Buffalo Niagara Medical Campus, as well as the city of Buffalo, and got to participate in fun activities such as icebreakers, educational learning activities, and problem-solving challenges. A little bit more about their research projects. I really wanted to focus in on risk mitigation of vascular disease. So how this worked is I split them into teams, and each team was assigned a contributing element to the development of vascular disease. They were all assigned a unique, different one. They were then tasked to find an area or population where both vascular disease and their assigned factor were prevalent and find a solution to address this. A caveat of this is they could not use Western New York as their population. Together, they came up with over 6 unique, thoughtful, and potentially life-saving solutions. So their topics were health literacy, food deserts, healthcare deserts, mental health, environmental factors, and genetics and generational circumstance. So our health literacy group focused in on the population of Jackson, Mississippi. Not only is vascular disease a very prevalent issue in the entire southeast of the continental United States, but Mississippi particularly has low rates of health literacy. If you're unaware of what health literacy is, it's the ability to understand and use health information to make informed decisions about one's health. For example, taking a certain medication or consenting to a treatment. Their solution to this was having a social worker come to local clinics, hospitals, community centers, churches, anywhere that the community really gathers to help explain medical jargon and ensure that the patients are understanding the information that they're receiving from their providers. A really interesting fact that they shared was that most health information about vascular disease is written at a 10th grade level or higher. Our next group was Food Deserts, and they focused on the Bronx, New York. Now, the Bronx is a food desert because most of their food access comes through highly processed food sold at bodegas, as well as fast food chains. Their solution to this was expanding the Green Cart Initiative. The Green Cart Initiative sells produce out of carts near areas in New York City with high foot traffic. Their other idea was to expand the Fresh program, which is currently being implemented in New York City. The Fresh program is the food retail expansion to support health program, which attracts and retains grocery stores in New York City and is currently only in 2 sections of the Bronx, but they're looking to expand this. They also want to provide community education so that when the residents of the Bronx are provided with easier access to nutritious food, they're more likely to choose it over the highly processed food options that are available to them now. Our next group was Healthcare Deserts, and they focused in on the entire state of Arizona. If you are unaware, Arizona both has high rates of vascular disease, but also has a very low ratio of doctors per 100,000 residents, and they have very few cardiologists. So their solution was the very prominent telehealth that we've seen more of after the COVID-19 pandemic. They also came up with a unique transportation method called UberMed, in which patients can schedule rides to their appointment. Depending on the patient's state of disease, there can be an EMT or a CNA riding along with them in the car to monitor the patient's status. They also wanted to create more mobile clinics and extend medical insurance if they can. Our mental health group focused in on the rural county of Mingo, West Virginia. So Mingo has high rates of vascular disease, but also high rates of mental health disorders and stress due to very high unemployment rates. If you're unaware, mental stress and vascular disease go hand in hand because it can lead to high blood pressure and very unhealthy coping mechanisms. So part of their solution was to draw attention to employment opportunities to help relieve some of the stress, as well as do community outreach using booths at local events to help destigmatize mental health disorders, and as well as incentivizing signing up for free counseling that they hope to provide the residents. Our environmental group went international and chose the country of Bangladesh. An interesting fact that they shared was that living in Bangladesh, breathing in the air is equivalent to smoking 2 cigarettes a day. Now imagine this over your entire lifetime. So their first solution was healthy air cleanup. As they did more research, they saw a statistic where per 10 decibels of sound that you're exposed to daily, your risk of having a stroke actually increases by 2%. So then they looked into sound reduction laws. They also focused in on clean energy, food education, and investments in medicine, as Bangladesh is also a food and healthcare desert. And finally, our genetics and generational circumstance group. They focused on the African American population in Atlanta and Los Angeles. This particular group has historically higher rates of vascular disease compared to different geographical regions as well as different ethnicities. So their solution was to build more trust within the African American communities because their trust was historically abused by healthcare through projects like the Tuskegee Project. They also are petitioning to make lipid panels the standard of care. If you're unaware of what a lipid panel is, it's a common diagnostic screening which basically just measures the level of fat in your blood. Usually your provider has to either recommend it or you have to ask for it yourself, but they're petitioning just to make it a standard of practice. Some other activities that they participated in this summer were touring the Jacobs School of Medicine, shadowing surgeons downstairs in our cath labs. This was a favorite. Playing games like J.I. Jeopardy. Now this got super competitive, which was super fun because I got to see how much they learned during their 2 weeks. I had a blast doing that one. They also participated in stroke empathy activities. An example of this would be writing with their non-dominant hand to simulate a loss of fine motor skills of someone who had just had a stroke and had brain damage. They also got to hear from our amazing guest speakers, so that's just Dr. Snyder lecturing to them. They really enjoyed that. I want to touch on the Mother Cabrini Health Foundation, who provided the JI a grant to make this all possible. They supported both our high school and college internships. Something really cool is our high school students, for the first time, were actually able to be stipend this summer thanks to Mother Cabrini. Mother Cabrini also made the college stipends possible as well. One of the missions of the Mother Cabrini Health Foundation is health career discovery, which really aligns with the objectives of the JI Next Gen High School Internship as well as our college internship. They also provided breakfast and lunch for the high school interns throughout their 2 weeks with us and are continuing to provide breakfast and lunch for the 7 high school students that are now placed in UB and Niagara labs. So my takeaways, I learned so much more about vascular disease than I previously knew from my anatomy and bio classes as a pre-med student. I also learned so much about medical devices and the innovation going on right here at the JI. I got to shadow in the cath labs, and I saw TAVRs being placed, which is transvascular aortic valve replacements. I also learned about carotid stenting and things that I had no idea even existed. Having no engineering or technology background, my fellow interns taught me so much, whether it was the basics of coding or what leveraging AI actually means. Thank you, guys. I also sharpened my organization and planning skills by planning and executing the Next Gen High School Internship. And the students were working in diverse groups of new people, but so was I. So it was a really cool learning experience for all of us. Overall, I had an absolute blast. It was the highlight of my pre-med experience and an extremely memorable summer. I just want to say thank you to everyone who made this possible. Thank you, Pam, Jess, Julia, Dr. Snyder, the high school cohort, my fellow college interns, and everyone at the JI. I really appreciate you all. Thank you. Now I'm going to pass it on to Docs, our communications intern.
Thanks, Katie. Now I'll walk you through how do we get the funds that we need for our, how do we need the philanthropic funds for all the programs that Katie was talking about. Good afternoon, everybody. Thank you for joining us today. I am Daksh Setia. I go to University at Buffalo, and I'm currently pursuing my MBA degree. I'm the communications and philanthropy intern here at JI. Thanks to Katie for giving me the free rein to add a pinch of marketing to it. So I'm going to tell you what I did this summer from a marketer's point of view, as I've been in the marketing industry for over 3 years. I did a lot of grant reading and writings. I shadowed surgeons. I did a lot of social media activities for JI, tried to get some nonprofit benefits, and then got a chance to sneak peek into the labs to do some photography and videography. So talking about those benefits that we got, the first one was we got ourselves registered in Google for Nonprofit program. What it does, it gives us access to Google Workspace, Google Ads grant, YouTube Nonprofit program, and then Google Map credits. Google Workspace, how much does it cost? As Bianca was telling that she's using Google Sheets, we use tools like Google Slides, Google Meet, etc., and it would have costed us somewhere around $880 per month as an organization to use the Google Workspace. But guess how much we paid for it? We got it at absolutely no cost. We paid $0 for it. Moving on to YouTube Nonprofit program. It's a platform owned by Google, and we want to make it really easy for anybody who is watching us live on YouTube to donate. So we have made it very possible for you to donate directly in our PayPal account, and YouTube is going to cover the transaction fees. We are now going to have a donate button on our YouTube channel as well as any sort of content that we post on YouTube. So everybody who's watching live, please subscribe our channel. Google Ads grant. So this is the most exciting part. We got $10,000 in Google Ad spends every month. That sums up to a total of $120,000 per annum. How are we going to use it? This is a set of keywords that's very relevant for us. And anybody who's searching for medical innovation on Google and is not aware about JI, it would have costed us somewhere around $1.69 to $10 to get that one user on our website. This is where we are going to use Google Ads grant and capture those audience. By capture, I mean reach. That's a very general marketing term that we use. Apart from that, we are also going to use this $10,000 for creating awareness for JI, doing more fundraising activities, as well as promoting our training and engineering programs. Coming on how are we going to track the performance, we are going to have a look at the CTR, that's click-through rate. We're going to see how many website visits we got and the amount of donations that we are getting through these grants. Almost everybody nowadays is using Facebook or Instagram. And we got ourselves registered for Meta Social Impact. We wanted to make it very easy and convenient for anybody who's interacting to us through this platform. So we'll now have a donate button on our Facebook and Instagram pages. And we'll also be having donate buttons in any sort of posts that we do on our social media. Grants pipeline. One of my key takeaways this summer was that grant outreach is not only about, it's not always about a yes. It's about building relationships and learning the new process and laying groundwork for future opportunities. So I applied to a lot of grants this summer: Mother Cabrini, PepsiCo, Marriott, NFTA, LinkedIn Ads Grant, New Era, Dunkin' Donuts. So these are the grants that we have submitted. Mother Cabrini, as Katie has already covered. The New Era, which is a hat company headquartered in Buffalo. Marriott, we requested for some Marriott Bonvoy points, which we can use as a referral item in our upcoming events. NFTA, interns like me, Carson, Derek, and a lot of other high school interns depend on NFTA for our commute to office. So we requested them if they could sponsor token transit passes for our interns. We did not get our luck this time with PepsiCo and Dunkin' Donuts, but we are going to try again in future. Up next is Sony. Once I was having a conversation with Jim, and I got to know that we have to rent a lot of audio-video equipments. So that gave me a thought on why not to reach out to Sony or Canon for like if they have a charity page or something. And then I discovered they have a charity page. We are going to apply for Sony grants in the future. We also realized a lot of young donors prefer quick and convenient way. So that's why we created a Venmo account. You might have seen a big QR code right outside the door. So the goal is to simplify mobile donations, and also we want to put the QR codes for our another events as well as for any social media posts that we do. So we had a lot of amazing moments that was happening in the labs or the events that we were having. I got a chance to capture it through my lens, and I curated a digital photo and video library which we can use for our further social media posts as well as for newsletter and other campaigns. So we did a lot of social media campaigning during this summer. I did a lot of social media posts on all our handles, as well as we had an intern takeover series where one of our interns used to take over our Instagram on every Tuesday. Another way to reach our donor is through newsletters. The JI Beat is our quarterly newsletter, and we try to showcase what are the developments and innovation that's happening at JI in the last quarter. And I was fortunate enough to get a chance to contribute to the content this summer. So to continue offering these meaningful internship experiences, we need to raise more philanthropic funds. I helped in launching the 2026 Youth Education Fundraiser, where I set up targeted emails for different set of audience, as well as created a donation form, and our goal for this summer is $10,000. So my experiences at JI have been truly amazing, and I have got memories of a lifetime. Shadowing doctors is something that I would have never dreamt of, being from a business majors, and in the marketing field, I would have never imagined going into a cath lab or shadowing any doctors. And I want this to be passed on to the next set of interns. I've made some really good friends, and beyond our day-to-day work, we also got an opportunity to go out with the JI staff. We went for the pickleball event, and last week we got a chance to go for the Bison's game. That was amazing, and I got a baseball back. So it was really a memorable experience. We also got a chance to go for the Tech Design Challenge that was held by Tech Buffalo, where we got a chance to meet interns from other organizations. And all of this was made possible because of donations. Now that I've made it so easy for you guys to donate, I'll request you guys to take out your phone, scan this QR code, and help us achieve the campaign goal. For today, our CEO, Dr. Adnan Siddiqui, is going to match all donations up to $1,000. And every dollar we raise brings us closer to helping more students explore career in healthcare and innovation. I thank you all in advance for your help, and that's all. I would now invite my fellow interns for Q&A.
Thank you so much to the interns for those beautiful presentations. They're all going to join us again, and we'll open the floor to questions.
Yeah, your first go ahead.
Carson, your mic fell.
Oh, what?
It's hanging on.
Okay, cool. Yeah, okay, go this way.
turn around.
So I have a question for those of you who are not from Buffalo. I'd love to hear about your impressions of Buffalo, what you were thinking when you were first coming here, like, oh my God, I'm going to Buffalo for the summer, and how you're thinking about it now.
I'd say I'm from California. Y'all don't realize how good your food is. Yeah, I've gotten quite the reputation for eating a lot. I don't know if that's the best reputation, but yeah, I go home on Saturday, so it's been like a food tour. They gave me 2 sets of silverware for how much food I ordered yesterday. So yeah, the food's good.
Branching off of that, my last slide, I think I pulled 70 shots of espresso here at the JI. But outside of the JI, I have visited we're going up on 20 coffee shops around Buffalo. And the food and drink scene is just phenomenal. I will miss it. I'm from New York City and Long Island. And Buffalo puts up just as good, if not better of a fight. And I just was amazed by it.
Yes, I'm going to take a different standpoint and talk about the weather. I know that the winters here can get a little brutal, but this summer has been amazing in terms of weather, and I know that if I was in Florida this summer, I would be sweltering. So it was such a good experience to be able to enjoy all the nature and get to run outside without hyperventilating.
I'm from Buffalo, so, it's always good to be home. I agree with you guys on the food. It's just you go away and it's not as good.
I mean, yeah, it has been a totally different experience for me. I was really excited for the winters because I was going to see snow for the first time. And then, after a week, I'm texting all my friends who are from here, how are you guys surviving in this weather? I'm not liking the snow anymore. And then it's not getting over for next 3-4 months. Nah. But yeah, summers have been wonderful.
So why don't you guys take turns and maybe just talk about one particular anecdote that you're going to take away with you as you go forward in your careers?
I feel like for me, the thing that's going to stand out the most definitely is just my exposure to the medical field. And I have a lot of family in the medical field, but getting to shadow open brain surgery, I'm like, pay them whatever they want. Like, it's insane stuff, and it really puts to show like how knowledgeable everyone is here. It really feels like, and I think the Jacobs Institute itself is just pretty incredible because it feels like every single person brings something to the table that it really feels like it wouldn't operate nearly as well as it does without it. There's no freeloaders. Everyone's bringing like their A game. And so I feel like every single person I've talked to, I learn a lot from. And I cannot say the same about basically everywhere else I've been. So it's just been an incredible experience. And yeah, brain surgery is crazy. Yeah.
Something that I learned, I talked about it a little bit earlier, but though I worked on a project that we didn't know a lot about, and in order to answer the questions that we needed to know, to move forward, we needed information quickly. So we needed a solution that we could implement very quickly and efficiently in order to answer those questions and then move forward. So something that I learned, I would say, is when you need a short-term versus a long-term solution for something. Is it something that you need to spend more time digging deep into, or is it something that you can kind of piece together and gather the information that you need and then move forward? So that's something I think that's very important in engineering, and definitely taking that and going forward into my career will be helpful.
I think the biggest takeaway, especially usually in engineering projects in college, you're one of maybe a few engineers, but overall you're working in a very small group. And I think my biggest takeaway, if we're talking anecdotes, I have one specific anecdote of just going up to Dan, and we went to a conference room and we were just drawing on a whiteboard for like an hour straight. There's a lot of talk about collisions between the two different fields, neuro and cardio. But I think immersing yourself and working with just as many engineers as possible, that analogy of collisions, I like to say like bouncing ideas off each other. I didn't realize how impactful it is. The progress that I made, it wouldn't even be a quarter of what it was if I hadn't had that chance to talk with everyone here at the JI. And that's why I like to reiterate just how special of an experience it was for me, because every day, not only was I learning something new, I realized that talking with other engineers, bouncing ideas off of them, it made me love this industry even more, and it made me realize, that's really where I feel alive.
Going kind of based off that, I think my anecdotes are kind of like all in one, is more like the collaboration and everyone willing to help the younger generation. I've experienced this in the JI during our lunch in the cafe with everyone collaborating on what they're doing. I've experienced this in surgeries with both the cath lab and open brain surgery, how all the doctors, nurses, and even the sales reps that I got to talk to were willing to give me all this information just to grow how smart I am and how much I know about the field. And I'm going to take that to know that I can contribute that to the future. And when I hopefully graduate medical school, I'll be able to be that doctor that fuels innovation within the younger generations.
Very nice. I learned a lot about the importance of variation. On a more serious and organizational note, to really keep the high school students engaged, you had to have a wide variety of activities, and they didn't really like when their day was repetitive. Another little bit more silly one is I was ordering catering and was trying to make it super inclusive for dietary needs. So I was like, oh, this is easy. I'll just order buffet style food. I ordered Mexican 4 days in a row. So I got a lot of notes about maybe can we switch up the Mexican food? So variation is really important.
And one thing that I learned from a marketing and communications point is we could do a lot of things for a nonprofit, which I was not aware of. So there's a lot of things that we can, get for nonprofits.
Is this on? Hello. Hi. So I know that some of you touched on this in your presentations, but if you had another, 8 weeks? 8 weeks? How many weeks? 10 weeks. Oh, okay. If you had another 10 weeks, what would you dive into next? Would you continue on? What would you change? What would you do next?
I think I would talk to the employees more. I've gotten, that's something I forgot to mention in the last question. I've gotten the best advice on everything. Every single person I've talked to. While I'm in college, I like to talk to people above me and get their input. But every single person I talk to at the JI, the Notes app is out. I study electrical engineering, and Steve showed me a better way of soldering than I've been taught. And I'm just learning so much, and I think just taking that away, I think that really just shines the light on the multidisciplinary nature of the JI. And I think I would, if I had more time, I think maybe bringing in a little bit more of my background and trying to see, because one of the things that's exciting for me is, now that I've gotten a taste of medicine, and I get an idea of what problems the medical field needs, I'm going to go back home to a lab full of electrical engineers that have absolutely no idea where the things could be applied to, and I could tell them things that can actually make a difference in the real world. And so I think just increasing that dialogue, that would be that has been the most incredible thing for me.
Something that I would do, I talked a little bit at the end of my presentation about how the mold material for dip casting is very important. I went on a whole adventure with a different mold material that was made of wax, and it reacted so strangely with the solution that we were using. And in order to kind of keep moving forward with the process, we were looking into that on the side, but also kind of focusing on using the different insert because it was working. I would love to kind of investigate that more and see why what was happening, and kind of take that into the process for the future.
They say that perfection is the enemy of just good enough. And I think that definitely applies, especially when you're under 10 weeks, which went by just so fast. I would love to go back to the drawing board and really see where can I improve things from the bottom up. I was not only making my project, but learning the skills necessary to do so. And I feel like even going back and redesigning and optimizing a lot of the cartridges that I made to really see where I can take them in terms of the quality, from a quality control standpoint, take it to the next step. That would take probably more than 10 weeks, but it'd be a great start, and yeah, these 10 weeks were amazing.
I'd probably do two things. I would definitely keep expanding onto the spreadsheet and adding more information to make it as best as possible, but I would also love to see it applied. I know Derek does, but I would also love to get into the 3D printing world and learn how, expand on my strengths within CAD software. I used to do it in high school, I did it a little bit in college, so that would be really great to experience, and just strengthening that skill set that I have and just seeing how my spreadsheet can actually be applied in real time.
I have two things as well. So the first one is I would love to host another cohort of interns. I had so much fun doing the first one, but if you didn't know, there were over 250 applicants for this high school internship. Also, after doing it, I have so many ideas for the program and things that I would love to implement. My second one is I'd also love to be a little bit more involved with the students who are now placed within our partner labs. This is because I actually did my undergrad research at UB through a program called CLIMB. So I feel that I have a little bit of insight into that, like your time window if you're in the lab to when your presentation has to be done and the peer review that goes into that. So I would like to be involved in that.
Yeah, I would do three things. The first thing is get more funds so that these guys work smoothly, and then increase JI's digital presence. And then I would also love to get more chances to shadow surgeries and go in cath labs, because that's really amazing.
I just want to say one maybe last thing, but I've probably come to more of these than most people, right? Yeah. But you're not ordinary. You are extraordinary. And not only did you convey great scientific information, but the way you could put that across with such ease and make it sort of understandable to someone like me. I am so really proud of you all, and I do not doubt that you're going to make the JI even better by your good ideas for the future. So I just thank you so much. It's just been absolutely wonderful. Thank you, Adnan. Thank you so much.
Thank you. Thank you.
Okay, that seems like all the questions. So like I said, please join us for the reception across the hall. There's a very large spread. We're going to need some help finishing it up.